So in this video lesson, we're going to have a look at velocity, and we're going to talk about speed. So velocity is how rapidly an object is moving over time. Okay, so velocity is essentially a measure of how an object is changing, how fast it's moving over a particular period of time. Velocity is a vector quantity, so it has direction. So just like displacement was a vector that had direction, velocity is also a vector that will have direction. The symbol for velocity is a V with our vector arrow over top. Okay, and so that's how we know that velocity is a vector. We have the vector arrow over top of the V, which is standing for velocity. There are two different types of velocity. So there is instantaneous velocity and then average velocity. So this one is instantaneous, and that means just at one moment of time only. And then we have average velocity, which is over a period of time. We are going to be calculating average velocity. We can't actually calculate instantaneous velocity. It's a difficult mathematical calculation to make. So we are going to be calculating average velocities only. So when we're calculating velocity, the average velocity is equal to our displacement over time. So in this formula, V average is representing our average velocity. Delta D with a little arrow over top is, of course, our displacement. We learned about that last week. And then delta T is going to represent our time. All right, so displacement, standard unit is to measure displacement in meters, and then time should be measured in seconds. So then our average velocity is measured in meters per second. And you will sometimes see it written as meters / seconds, and that's okay. Either one of those is an acceptable unit for average velocity. So to calculate our average velocity in meters per second, we're going to take our displacement in meters and divide it by our time in seconds. Okay, these are the standard units for velocity, displacement, and time, and we should only be using this equation with those units. Okay, we can use some other units for displacement like kilometers or feet or yards if we want to. And we could use a different unit for time if we wanted, like hours. But then our velocity is going to be in those displacement units over time units. So sometimes that means velocity is measured in kilometers per hour, as an example. When we're talking about velocity direction, since we know that velocity is a vector, so the velocity direction is the same as the displacement direction. So whatever direction our displacement is in, our velocity is going in that exact same direction. So our velocity direction is going to be the same as the displacement direction. Okay, so we're going to talk about another concept called speed. And speed is how rapidly something is moving over time. But the difference from velocity is that it has no direction. So speed is represented by just a capital V, and it is a scalar quantity. So there is no direction associated with speed. So when we're calculating speed, by calculating speed, we're going to do our distance divided by our time. So notice that the formula looks very similar, except we are not using vectors. So V is representing speed. Delta D we know is distance. We learned about that last week. And then our delta T here is representing time again. So to calculate our speed, we're going to do our distance divided by our time. So distance is going to be, of course, measured in meters. Time is measured in seconds. So that means that speed is measured in meters per second. So speed formula is almost identical to the velocity formula, with the difference being to calculate speed, we are going to use distance. When we were calculating velocity, we used displacement. So to calculate speed, we're going to use distance. Okay. Speed does not have a direction associated with it. Neither does distance. So there is no direction associated with our speed. All right. So we are going to do a practice question that has to do with speed and velocity. Okay. So I have Jack and Jill are racing each other. They both start at their house. Jack runs 10.0 kilometers west, 8.00 kilometers east, and then 6.00 kilometers west. Jill runs 6.00 kilometers west, 7.00 kilometers east, 5.00 kilometers west, 2.00 kilometers east, 3.00 kilometers west, and then lastly 1.00 kilometers east. It takes each of them 2.5 hours to run their respective routes. So in this question, I'm going to ask you to, for both Jack and Jill, I want you to find the distance that they traveled. We're going to find the displacement that they traveled. We're going to find the speed that they traveled. And then we're going to find their average velocity as well. Okay, so I'm going to start off with Jack. And I'm going to highlight Jack's route in green. So he's going 10 kilometers west, 8 kilometers east, and then another 6 kilometers west. So for Jack, his distance is going to be 10 kilometers plus our 8 kilometers plus our 6 kilometers. So his distance is going to be 24.0 kilometers. Okay, remember, distance is the entire route that Jack traveled. So he went 10 kilometers, 8 kilometers, 6 kilometers. So in total, he's gone 24 kilometers. Jack's displacement, remember, we have to add them up using our directions. So it would be 10 kilometers to the west. And then since he went 8 kilometers east, I'm going to change that to west and say that's negative 8 kilometers west. And then he's also going another 6 kilometers west. So now I have 10 minus 8 plus 6 is going to give me 8 kilometers to the west for Jack's displacement. Okay, to calculate Jack's speed, we're going to do his distance over time. And so the distance he traveled, we knew was 24.0 kilometers, and he did that in 2.5 hours. So that's going to give us 9.6 kilometers per hour for his speed. His velocity, we're going to calculate using our displacement over time. So his displacement was 8 kilometers to the west, and he did that in 2.5 hours. So that's going to give us a velocity of 3.2 kilometers per hour, and he's still traveling to the west. All right, so then let's go back and look at our question again, and we're going to calculate Jill's distance, displacement, speed, and velocity. So for Jill, she ran 6 kilometers west, 7 kilometers east, 5 kilometers west, 2 kilometers east, 3 kilometers west, and then 1 kilometer to the east. So for Jill, we'll start with her distance. So she went 6 kilometers, 7 kilometers, 5 kilometers, 2 kilometers, 3 kilometers, and 1 kilometer. So she went 24 kilometers. Hey, she traveled the same distance as Jack. For Jill's displacement, remember we have to use our directions. So she's going 6 kilometers west, and then 7 kilometers east, so that's negative 7 kilometers west, and then another 5 kilometers west, and then 2 kilometers east, so that's negative 2 kilometers west, and then another 3 kilometers west, and then another 1 kilometer east, so that's minus 1 kilometer west. So that's going to give us a total displacement of 4 kilometers to the west. So we did our 6 minus 7 plus 5 minus 2 plus 3 minus 1, giving us our 4 kilometers to the west. So Jill's speed is going to be her distance divided by time, but since her distance was the same as Jack's, her speed is going to be the same as Jack's because they both had the same time. So she's also going at a speed of 9.6 kilometers an hour. Her velocity is going to be her displacement over time, and her displacement is 4 kilometers to the west, and her time was still 2.5 hours, so giving us a total of 1.6 kilometers per hour to the west. So Jill's velocity is quite a bit lower because she has a smaller displacement. All right, so when we're comparing speed to velocity, so speed is represented by a V, velocity by our V with our vector arrow over top. The units for speed are meters per second. They're the same for velocity. Our formula for speed is distance over time, and our formula for velocity is displacement over time. So speed is based on distance, and velocity is based on displacement. Speed is a scalar quantity, and velocity is a vector quantity. So it has direction associated with it. Okay, so that's it for this video lesson on speed and velocity. There are some practice questions to be doing to do with speed and velocity, but that's the end of this video lesson.